Okay, this is a walkthrough of a one-dimensional motion problem where the object is in free fall or projectile motion. So let's say that an object is launched straight up from a height of 5 meters with a starting speed of 8 meters per second. And we want to know how long does it take, that's an elapsed time, does it take for the object to reach the highest point in its flight? Second, we want to know how high it is at the highest point. Third, we want to know how long in elapsed time before the object hits the ground. So that's the total time from when it's launched to when it hits the ground. And then finally, what's the velocity of the object at the instant right before it hits the ground? So what's the velocity just before it hits the ground? These kind of problems are, they're constant acceleration problems, and we're going to use the constant acceleration equations. The real only difference is that you always know what the acceleration is in free fall and projectile motion. You always know that the acceleration is 9.81 meters per second squared down. Whether the object's going up or going down at that instant, the acceleration is still down at 9.81 meters per second squared. Okay, so first I'm going to just draw a little sketch of what's going on. So it's launched from this height of 5 meters. And it goes straight up and straight down. Okay, it's a one-dimensional motion, so it's just going straight up and straight down along the same line. And it's launched up at 8 meters per second. Okay, so for part A, we're going to do each of these parts separately because you always have to think if anything has to change. So first, ask yourself, what's the first step in problems like this? So pause the video for a second and ask yourself, what's the first step? And then, okay. So the first step is to choose those 4 things. We have to choose a time equals 0 instant, a time final instant, a location that we're going to call position equals 0, and a positive direction. Well, for part A, we're trying to find out something when the object reaches its highest point. And we have information when it's launched. So pause the video for a second and see if you can fill out this table. Before you do that, sorry, the position equals 0 and positive direction, remember, are arbitrary. So you can really choose anything for those. So just so we're on the same page, I'm going to tell you on these free fall problems, I pretty much always choose my position equals 0 to be at the ground and my positive direction to be up. I think it helps to sort of always approach those the same. Okay, now pause the video for a second and see if you can make the two choices of the instance for time equals 0 and time final. Okay, well, time equals 0 has to be when it's launched because we have a lot of information there. And time final has to be when it reaches the highest point because that's where we're looking for information. Okay, now ask yourself, what's the next step? What do we do next? The next step is we want to fill out what we know and what we want. And I'm going to go through in order. So pause the video now and see if you can fill out this table of the variables you know and the variables that, or the one variable you're looking for part A. Okay, so for part A, we're looking for the elapsed time when it reaches the highest point. That's what the stopwatch will say when the object gets to the highest point. And so time final is what we're trying to calculate. The acceleration, we know, it's downwards at 9.81 meters per second squared. Since our positive is up, downwards is negative, so this is negative 9.81 meters per second squared. The position at time equals 0 is, so if I draw the position, it's this red dot here. Well, that's, if our 0 is here and our positive is this way, then that red dot is 5 meters in the positive direction from 0. So that position is going to be positive 5 meters. Our final position, we don't know. We don't care yet, although we are going to care when we get to part B. But for now, we'll leave it out. Initial velocity. Do we know the velocity at time equals 0? Well, we know the speed is 8 meters per second. So to turn that speed into a velocity, all we have to do is figure out whether it's going in the positive or negative direction. It's going up, which we've declared to be our positive direction. So this starting velocity, this initial velocity, is positive 8 meters per second. And then finally, do we know the final velocity? Do we know the velocity at time final? Well, time final is when it reaches the highest point. And whenever you hear about an object, whenever a problem says something about the highest point, you know you're going to use the fact that the velocity at that instant is 0. So that you can think of that as like the definition of reaching the highest point. So V final is equal to 0. And now, is there an equation that has TF in it and everything else in it is given here? Pause the video for a second and see if you can find that equation. Okay, well, the equation that's going to work is V final is equal to V initial plus A times time final. If I fill this out, we got 0 is equal to 8 meters per second plus negative 9.81 meters per second squared times time final. Now, see if you can work through the algebra of this to find time final. So pause the video now and do that. Okay, well, to do that, I'm going to subtract this whole term from both sides, which means adding 9.81 meters per second squared times time final to both sides. So now that's equal to 8 meters per second. Now I'm going to divide the stuff in parentheses from both sides. So time final is equal to 8 meters per second divided by 9.81 meters, with now the seconds times seconds. Since we're dividing, they go in the numerator. You cancel one of these seconds, you cancel the meters, and we end up with a time of 8 divided by 9.81 is 0.82. The units we have left are just seconds, which makes sense for a time. And so that's the answer for part A. For part B, now we want to figure out how high the object is at the highest point. So think, before we start, or in the first step, is there any reason to change either our time equals 0 instant or our time final instant? There's definitely no reason to change position equals 0 or positive direction, but think about those two times. Well, no, we're still trying to calculate something at the highest point. We still have a lot of information at that starting point. So we're going to keep those same, time equals 0 and time final. We're going to just keep those the same as they were before. Well, what that means is anything we knew before, we know now. And now we have the additional information that time final is 0.82 seconds. So I'm going to fill this out. We have time final is 0.82 seconds. Acceleration is negative 9.81 meters per second squared. P initial is positive 5 meters. We're looking for P final. V initial is positive 8 meters per second. V final is 0. So now, is there an equation that works for calculating P final here? Pause the video and see if you can find that equation. All right, well, the equation that's going to work with this information is P final is equal to P initial plus V initial times time final plus 1/2 A times time final squared. So P final is equal to 5 meters plus 8 meters per second times 0.82 seconds plus 1/2 times negative 9.81 meters per second squared times 0.82 seconds squared. The way the units will work is these seconds will cancel. The seconds squared here, because you're squaring this term, will cancel the second squared there. And so everything will end up in meters. And so your final answer is going to be in meters. And so now all you have to do is go through that calculation. Pause the video and calculate PF. Okay, so plus 8. Sorry, I'm just doing this on the calculator right now. And we get that the highest point that this reaches is going to be about 8.26 meters. Okay, so that's part B. Now we're going on to part C. And we're trying to calculate the elapsed time for when the object hits the ground. We can keep our position equals 0 and our positive direction the same, but think for a second about whether we need to change either our time equals 0 or our time final. Pause the video and see if you can figure out what we're going to use as our time equals 0 and time final. Okay, well, there's no reason to change our time equals 0. That's still going to be the instant that it's launched. But time final we have to change because now we're looking for information when the object hits the ground. Or you can think of it as the instant just before it hits the ground. Or you can think of it as the ground is gone and it's when the object reaches the level of the ground. But this time we have to choose our time final to be the instant that the object reaches the ground. The key thing to remember here is that you can't assume this is right as the object hits the ground because it wouldn't be in free fall anymore. So you have to either think it's right before it hits the ground, or you have to think that the ground disappears and it's when it reaches that location. The next step is to go through what we know and what we want. So take a second, pause the video, and see if you can fill this out. Well, we're looking for time final. The acceleration, since it's in free fall, is still down at 9.81 meters per second squared. And down is negative for our choice of up being positive. Position equals 0 is 5 meters. Position final, this time we know the position final going into it because it's at ground level and our 0 position is on the ground. So this is 0. Our initial velocity is 8 meters per second, and we don't know our final velocity. We're going to want to calculate that in part D. Okay, so now we have to see if there's an equation that'll let us solve for this. So pause the video and see if you can find an equation that'll work. Well, the equation that'll work to calculate time final is this one. PF is equal to PI plus VITF plus 1/2 ATF squared. That's a little bit of bad news because we're going to have to use the quadratic formula to do this, but once you get used to that, it's not a major problem. But notice that the reason we have to use the quadratic formula is that the variable we're solving for has a squared term and a linear term, and there's a constant. And so we just have to use it. But if we fill this out, we get P final is 0. Whenever I use the quadratic formula, I'm going to leave the units out of it. We'll just trust the units when we use the quadratic formula. It gets too complicated. But we have 0 is equal to 5 meters plus 8 times time final plus 1/2 times negative 9.81. So I'm going to just write this as, come on, erase, negative 4.905 time final squared. So I just combined the 1/2 and the negative 9.81. And now to use the quadratic formula, this is your a because it's the coefficient of the squared term. This is your b because it's the coefficient of the linear term. And this is your c. And the answer for time final is negative b, this is the quadratic formula, plus or minus square root of b squared minus 4ac all over 2a. And if you answer that, you get negative 0.48 or positive 2.11. Okay, whenever you get two answers in this class, you have to think about why we want one and why we don't want the other one. So think for a second, which one of these do we want? The answer is easy anytime in this class. We're looking for a time. Well, anytime there's a negative time is one of your answers, I guess. Sometimes you have to think a little more about it, but we're never using negative times. We're always setting ourselves up where time equals 0 is the earliest thing in our calculation. And so we're rejecting the negative, and that means 2.11 seconds is the answer. I'll put the units on here. So there's the elapsed time for it to reach ground level. Now the last thing that we're trying to calculate is what's the velocity just before it hits the ground. Okay, so is there any reason to change what we're calling time equals 0 or time final? No, we still want our time final to be when it hits the ground. So these are still the same. Okay, so whenever that's the same as it was in the last part, we still know everything we knew in the last part, plus whatever we calculated in the last part. So pause the video and fill out this table. Time final is equal to 2.11 seconds. Acceleration is negative 9.81 meters per second squared. P initial is 5 meters. P final is 8 meters per second. V initial is, I'm sorry, that was wrong. P final, I like trying to think while I talk. So P final is 0, right? At time final, the height is 0 when it hits the ground. V initial is 8 meters per second. And what we're trying to find is the velocity at time final. So what equation can we use? There are two equations that we can use here. One is this one. And one is this one. Well, if you have more than one option, you might as well always use the simpler one. This one deals with squares. You're going to have to think about the signs of your answers. It's just easier to go with this one. Okay, so let's plug these values in. So V final is equal to 8 meters per second plus negative 9.81. So I'll say that is minus 9.81 meters per second squared times the time final that we just calculated, which was 2.11 seconds. So go through the algebra and calculate that V final. The way the units are going to work, this seconds is going to cancel one of those 2 seconds. So each of these terms is just going to be meters per second, which is the units we want for V final. So that's good. And let me plug this in quickly. So we have 8 minus 9.81 times 2.11. And we get an answer of negative 12.70 meters per second. As a sanity check, think for a second, does it make sense that we're getting a negative answer for this final velocity? It does make sense because our positive direction is up, and when this object gets back to ground level on the way down, it's going to be moving down, which is negative.